Problem number 30 here has some instructions a little higher up. It says you roll a pair of number cubes 60 times. You record the results in the bar graph shown. So use the bar graph to find the experimental probability of rolling each sum. Is each sum equally likely? Explain. If not, which one is most likely? So all of these, the probability of rolling a 2, for example, or rolling a 3, all I'm really doing is pulling information off of the bar graph. So this was the experiment that we did, rolling the dice 60 times. And in those 60 rolls, we got a sum of a 2 twice. So there was times that we rolled a sum of a 2. It happened twice. So this is the sum that we rolled. This is how many times we rolled it. A sum of a 3 was rolled 4 times. A sum of a 4 was rolled 5 times. So as I look at this data and start going through the question again, I know that they're not equally as likely as I look at these. And I'm going to go in and explain a little more how I'm going to defend that answer using the data. So what I'm going to do first is go through and just write out all the numbers, the probability, do some counting, and see what numbers I can pull off of here and write it all down down here. So here I have all of my my numbers written out. I don't know what happened in my head, but I was going, all the way up to 5, and for some reason I jumped to 10. I think it's because I did 1/10 on the 5, so I jumped over and went there. But I kind of tried to fill it in. So these should really be in order to just be a little more easy to understand. But when I was writing them down, I kind of jumped around a little bit. But we can see that these numbers are quite different. There's some that are the same. So the probability of getting a 2 is the same as the probability of getting a 10. We can see that up here. They have the same height. The bars are the same height in the bar graph. So I kind of knew that anyway, but that's really what this is saying. Is each sum equally likely? And the answer is no. For example, these sums that are in the middle, 6, 7, 8, and 9, those are much more likely to show up. I got a 12, it looks like one time. So probability of a 12 is 1 out of 60. So that means of these 60 rolls, we got a 12 one time. So that's pretty unlikely compared to something like rolling a 6. The probability of rolling a 6, out of the 60 rolls, that happened 13 times. So is each sum equally as likely? No. My explanation of that is that there's much more ways to roll some of these numbers in the middle. To roll a 6, I could roll a 4 and a 2. I could roll a 5 and a 1. I could roll a 3 and a 3. So there's more possible ways to generate that 6. In order to roll a 2, I have to roll a 1 and a 1. There's very few ways to do that. In order to roll a 12, I have to roll a 6 and a 6. It's my only option. So that's sort of my explanation of why these are different. I can see it in the numbers. I can see it in the bar graph. The taller bars are more likely, have more of a chance for them to happen based on the experimental probability here. The other part of this too, it says, if not, which is most likely? According to this data, rolling a 6 is the most likely, followed by rolling a 7. There's just a couple little differences here between the 8 and the 9, but those numbers in the middle tend to be much more frequent.